Hello everyone, am I audible? Please let me know if I'm audible. Welcome dear students. Please let me know if I'm audible. Okay, so here on behalf of Intelletics, we are conducting up this session, a revision session for 10th standard ICSE students, subject chemistry, chapter number 2, that is chemical bonding. We have already done the first chapter. If you have missed it by any chance, I request you all to go to the playlist and check for the videos which have been already uploaded. So let us start revising this chapter, chemical bonding. See, in this sessions, we are going to cover up only the important points. Okay, because if you start reading the textbook, no doubt the textbook reading is essential, it's mandatory. But right now, we don't have that much of time because we also have the scheduled papers to be solved. So, for this reason, we are going up only with the quick revision of all the chapters that are possible here, and that's the reason the first chapter has been already done, and now we are here with the second chapter, that is chemical bonding. So we are just going to talk about the important points that are worth remembering in exam point of view, in understanding point of view. So here we start with, if you're new to the channel, please subscribe to our channel and hit the bell icon so that you get to know when we come for the live streaming, next session of the live streaming, with some new chapter or maybe a test. Okay, I mean the MCQs to be done. So I start with first point. An atom is electrically neutral. The number of positively charged particles, that is protons, are equal to the number of negatively charged particles, that is electrons. Every atom tries to attain the stable electronic configuration of nearest inert gas, that is 8 electrons in the valence shell, except helium, which is having 2 electrons in the valence shell. Atom attains the stable electronic configuration by either losing, gaining, or sharing electrons. Now let us understand what is meant by an ion. When an atom loses or gains electrons, it gets converted into electrically charged particle, which is called as an ion. What's a cation? When an atom loses electron, it gets converted to positively charged particle called as cation. When an atom gains electrons, it gets converted to negatively charged particle that is called as anion. Now, what is meant by electropositive elements? The elements which easily lose electrons and acquire positive charge are called as electropositive elements. Metals are electropositive elements. Examples: sodium, that is Na plus, potassium, that is K plus, calcium, that is Ca2 plus, magnesium, that is Mg2 plus, aluminium, that is Al3 plus, etc. Now, what are electronegative elements? The elements which easily gain electrons and acquire a negative charge are called as electronegative elements. Non-metals are electronegative elements. Example: chloride, bromide, iodide, fluoride, oxide, sulfide, nitride, etc. So it's Cl minus, Br minus, I minus, F minus, O2 minus, S2 minus, N3 minus, etc. Now, what's meant by an ionic bond? The bond which is formed as a result of transference of electrons from the outermost shell of a metal to the outermost shell of a non-metal is called as ionic bond or electrovalent bond. Now, ionic bonds are formed between metals and nonmetals. Metals lose electrons and nonmetals gain electrons. For example, NaCl. So the electronic configuration of NaCl, Na is 281 and that of Cl is 287. You can clearly see that sodium has only one electron in its outermost shell. So it will require 7 more electrons to complete the octet, whereas chloride has 7 electrons in its outermost shell and it just needs only 1 electron to complete its octet. So what happens is the electron from sodium is taken by chloride. So sodium is donating its electron. Now when it donates its electron, that is its number is 11, right? So it has 11 protons and 11 electrons originally. But now when it donates one electron, so it has 11 protons but 10 electrons. So it has one positive charge extra because it has one proton extra. That's the reason it's now called as Na plus ion. Whereas chloride, which had 17 as the number, so 17 protons and 17 electrons. After gaining an electron, it now has 17 protons but 18 electrons. So it has one electron extra and that's the reason we call it a Cl minus. So when it's only minus, that means it has one negative charge extra. Okay, so NaCl, they form a bond and there are electrostatic forces of attraction. Okay, and the bond that is formed in between them is either called as the ionic bond or electrovalent bond. Now, as a result of transference of electrons, ions are formed which are held by strong electrostatic forces of attraction. The metals participating in an ionic bond formation should have low ionization potential. The nonmetals participating in an ionic bond formation should have high electron affinity. The chemical compounds formed as a result of the transfer of electrons from the outermost shell of a metal to the outermost shell of a nonmetal are called as ionic or electrovalent compounds. The compounds formed by the transference of electrons are called as ionic or electrovalent compounds. Now coming to the next, that is the properties of ionic or electrovalent compounds. So let us talk about the properties of ionic or electrovalent compounds. First, ionic compounds are hard solids as their constituent particles are ions which are held by strong electrostatic forces of attraction and hence they cannot be separated easily. Friends, this can be asked to you as an MCQ. Why is that the ionic compounds are hard solids? A, because ions are held by strong electrostatic forces of attraction. Second, they are held together by, let's say, magnetic forces. Third, by gravitational forces. Fourth, all of these, something like that. Now, coming to the second property, ionic compounds have high melting point and boiling point. They are non-volatile solids. As in these compounds, ions are held by strong electrostatic forces of attraction. So large amount of energy is required to overcome these forces of attraction between the ions. Ionic compounds do not conduct electricity in the solid state. However, they can conduct electricity in the fused, molten and in their aqueous solution. In solid state, they do not conduct electricity as the ions are not free. They are held together by strong electrostatic forces of attraction. However, in their molten state, the strong forces of attraction get weakened and thus the ions become free to conduct electricity. In aqueous solution, the high dielectric constant overcomes the strong electrostatic forces of attraction and thus the ions become free to carry the electric current. Ionic compounds, on dissolving in water, allow the passage of electric current through them as the ions become free. Thus, they act as strong electrolytes. Coming to the next, ionic compounds are soluble in water, but they are insoluble in organic solvents. As water has maximum dielectric constant, Therefore, it decreases the force of attraction between the ions and thus it forms free ions and hence they dissolve. On passing electric current through molten, fused and aqueous solution of ionic compounds, the ions dissociate and migrate towards electrodes. Ionic compounds undergo fast reactions in their aqueous solution. Keep this in mind. I can ask you, why do they undergo fast reactions in the aqueous state and not in the solid state? Something like that can be asked to you. Now, let us understand the next, that is covalent bond. The bond which is formed as a result of mutual sharing of electrons is called as covalent bond. Please remember, co is cooperation. So they cooperate with each other by sharing. Like when you share something with your friend, so it's like you're cooperating with each other. So you can keep this as a clue and remember that covalent is the bond in which it is formed due to the sharing of the electrons and not exchange altogether. The covalent bond formation takes place between two non-metallic elements. When the same or different non-metallic atoms present in the groups 14, 15, 16, 17 of the periodic table combine together, covalent bonds are formed. Both the atoms participating in covalent bond formation should have high electronegativity, high ionization energy, and high electron affinity. During covalent bond formation, ions are not formed, only molecules are formed. Now, coming to the next, non-polar covalent compounds. The covalent compounds in which the combining elements have no or very slight difference in their electronegativity are called as non-polar covalent compounds. For example, hydrogen, chloride, nitrogen, oxygen. All hydrocarbons are non-polar covalent compounds, that is, methane, ethane, ethene, ethylene, and carbon tetrachloride. So please remember the covalent bonds in which the combining elements have no or very slight difference in their electronegativity are called as non-polar covalent compounds. Now, coming to the next, that is a single covalent bond. A single covalent bond is formed by the sharing of one pair of electrons between the atoms. Each atom is contributing only one electron. So a single covalent bond is denoted by putting a single short line between the two atoms. So if I take an example of hydrogen molecule, we write it as H dash H. You can see on the screen here. So it forms H2. Here you can clearly see that it is just sharing up one electron each. Coming to the next, formation of chlorine molecule with an atomic number of 287. So what happens is, as you can see, chlorine molecule has 17 electrons. So the last shell has only 7 electrons and it needs only 1 electron to complete its octet. So it shares this electron with another chlorine which is also in search of one more electron to complete its octet. So it forms a single bond, and such a bond is called as a single covalent bond when a single pair of electrons is being shared between two atoms. Now coming to the next, that is a double covalent bond. A double covalent bond is formed by the sharing of two pairs of electrons between the two atoms to acquire stable electronic configuration. A double covalent bond is denoted by putting a double line between the two atoms. For example, formation of oxygen molecule. Now oxygen, has altogether 8 electrons. Its number is 8. So it has 2 electrons in the first shell and 6 electrons in the second, that is its outermost shell. So it needs 2 more electrons to become stable, or that is to complete its octet. So this oxygen with 2 electrons in need combines with another oxygen which also needs 2 electrons to complete it, right? So what happens here is two pairs of electrons are shared between the two atoms. So we write it as O double bond O, that is O2. I hope you've understood it. Now coming to the next, that is a triple covalent bond. A triple covalent bond is formed by the sharing of three pairs of electrons between the two atoms. A triple covalent bond is denoted by putting three short lines between the two atoms. For example, formation of nitrogen molecule. Now you can see that nitrogen has just 7 electrons. So it needs 3 electrons each to complete its octet. Right? So what happens is the two nitrogen atoms, they share up these electrons, and that's the reason why while we write it, it is N triple bond N. That is N2. Now coming to the next, that is polar covalent compounds. The covalent compounds in which the combining elements have large difference in their electronegativity are called as polar covalent compounds. Example, hydrogen chloride gas, that is HCl, water, that is H2O, and ammonia, that is NH3. In case of hydrogen chloride gas, chlorine is more electronegative than hydrogen. Therefore, chlorine attracts the shared pair of electrons towards its side. Hence, chlorine acquires a partial negative charge and hydrogen acquires a partial positive charge, and thus the bond becomes polar. So here you can see the diagram, mutual sharing of the electrons between hydrogen and chlorine. So chlorine is more electronegative than hydrogen. Now, the compounds formed by the mutual sharing of electrons are called as covalent compounds. Now let us understand the properties of the covalent compounds. First, covalent compounds are liquids or gases. They constituent particles or molecules which are held by weak van der Waals forces. Very, very important. Covalent compounds are volatile compounds with low melting point and boiling point. As in these compounds, the molecules are held by weak van der Waals forces, so less amount of energy is required to overcome these forces of attraction. Covalent compounds do not conduct electricity as they do not contain ions. They only contain molecules. On passing electric current through the covalent compounds, they do not ionize as they contain only molecules and not ions. However, polar covalent compounds on dissolving in water produces ions, and thus they can act as electrolytes. Covalent compounds are insoluble in water but soluble in organic solvents. Covalent compounds only contain molecules and the dissociation to ions does not take place. Covalent compounds undergo slow speed of reactions. Now here's a tabular form for you to understand the differences between ionic compounds and covalent compounds. Ionic compounds are solid, whereas covalent compounds are liquids or very soft, waxy solids. Ionic compounds have high melting point and boiling point, whereas covalent compounds have low melting point and boiling point. Third, ionic compounds do not conduct electricity in the solid state as the ions are held by strong electrostatic forces of attraction, but they easily conduct electricity in the fused, molten or aqueous solution, whereas covalent compounds do not conduct electricity because the ions are absent, only molecules are present. Point number 4. Ionic compounds are soluble in water, whereas covalent compounds are insoluble in water but soluble in organic solvents. Next point, ionic compounds undergo fast reactions, whereas covalent compounds undergo slow reactions. Coming to the next point, reduction is the process of gain of electrons. It takes place at cathode. During reduction, cation gains electrons and gets converted into neutral particle. Example, Na plus E minus becomes Na. Oxidation is a process of loss of electrons and it takes place at anode. During oxidation, an ion loses electrons and gets converted to neutral particles. Example, Cl minus E minus gives you Cl. So 2 of Cl gives you Cl2. I mean 2 atoms of Cl combine together to form one molecule of chloride. Reducing agents are electron donors. That is, metals are the reducing agents. Oxidizing agents are electron acceptors. Non-metals are oxidizing agents. Reducing agent during the reaction gets oxidized and oxidizing agent during the reaction gets reduced. Very, very important. Now, consider the following reaction so that we understand it better. First reaction, CuSO4 plus Fe gives you FeSO4 plus Cu. So Cu2 plus, that is its ionic form, it has 2 protons extra. So it accepts 2 electron and it gets neutralized to form Cu. That is, it undergoes reduction. Whereas Ferrous, it accepts 2 electrons. So rather it donates 2 electrons and it becomes Fe2 plus. So it undergoes oxidation. Copper ion gets reduced and iron metal gets oxidized. Thus, copper sulfate is an oxidizing agent and iron is a reducing agent. Coming to the next example, Mg plus Cl2 gives you MgCl2. Now, Mg donates 2 electrons and becomes Mg2 plus, whereas chloride accepts 2 electrons and becomes 2Cl minus. Magnesium is getting oxidized and chlorine is getting reduced. Thus, magnesium is the reducing agent and chlorine is the oxidizing agent. Now, coming to the next, the structures of few electrovalent compounds are given. You can have a close look on the screen. You have magnesium chloride and calcium oxide as an example. The magnesium chloride has magnesium and chloride, wherein magnesium has the electronic configuration of 282 and chloride with an electron configuration of 287. So magnesium, it loses 2 electrons and it becomes Mg2 plus. Chloride, it accepts 2 electrons and it becomes 2Cl minus. So Mg2 plus 2Cl minus gives you MgCl2. Now coming to the example of calcium oxide, wherein calcium has the atomic number, the electronic configuration 2882, and oxygen with the electronic configuration of 26. So calcium loses 2 electrons and oxygen accepts the same 2 electrons. So it becomes Ca2 plus and O2 minus. So Ca2 plus O2 minus gives you CaO, that is calcium oxide. Coming to the next, the structures of few covalent molecules are given. First is hydrogen. Okay, you can see that it has a single covalent bond. So we write it as H, a single dash H. A single covalent bond is formed between 2 hydrogen atoms to form a molecule. Then we have chlorine, Cl2. So even here, a single covalent bond is formed between 2 chlorine atoms to form a molecule. Then we have nitrogen, that is N2, wherein a triple covalent bond is formed between 2 nitrogen atoms to form a molecule. Then the fourth example is oxygen, wherein we write it as O double bond O. So a double covalent bond is formed between 2 oxygen atoms to form a molecule. Now the next example is water, that is H2O. Oxygen atom has electronic configuration of 2,6. It has 6 electrons in its valence shell and achieves an octet by sharing 2 electrons, one each, with hydrogen atom. So you can clearly see this in the image. So you can see oxygen at the center and 2 hydrogen on the sides of oxygen. The next one is ammonium Nh3. Nitrogen atom has 5 electrons in its valence shell and can achieve an octet, that is stable configuration, by sharing 3 electrons, one each with 3 hydrogen atoms. So you can again see the structure very properly. Then we have carbon tetrachloride, that is CCl4. Carbon has 4 valence electrons. It can achieve octet by sharing 4 electrons, one each with 4 chlorine atoms. Coming to the next, that is methane Ch4. Carbon atom has 4 electrons in its valence shell. In order to complete its octet, it shares 4 electrons, one each with 4 hydrogen atoms. So it forms CH4. Coming to the next, that is coordinate bond. The bond in which the sharing of electrons takes place on the part of entirely one atom is called as a coordinate bond. The formation of hydronium ion takes place by coordinate bond formation. So hydronium ion is formed by the combination of H2O plus H plus. So you can look on the screen and understand why is it called as a coordinate bond. The pair of electron which does not take part in the bond formation is called as a lone pair of electron. Please keep this in mind. The formation of ammonium ion also takes place by coordinate bond formation. NH3 plus H plus. This is how we get the NH4 plus ion. So friends, we have done the important points of the second chapter, that is chemical bonding. Okay, so as I said, can you please stay connected, please hook on to this channel, because we are going to do only the important points from every chapter. We shall first read this and then start with the paper solving sessions, and this is going to be done for both chemistry and biology, but first chemistry of course, because Monday you are writing your chemistry paper. So friends, if you are new to the channel, please subscribe and spread a word about this channel to all your friends, so that all your friends can be benefited by this. See, sharing knowledge is the wisest thing that you can do. So please, please, please ask your friends to join in, and tell them to subscribe for this channel and hit the bell icon, so that you get to know when we shall be back again for another live streaming session. Till then, thank you so much for staying connected.